upper limit. So we have computed LCF. We have got our n by 2 as 521. We'll select the interval which has LCF greater than 521, which is 50 to 60. So 50 is the lower limit. Frequency is 389. Previous class intervals LCF, that is our CF, which is 380, and H is upper limit minus lower limit, 60 minus 50, which is 10. So first do the subtraction, then multiplication, division, and then the addition. So when I do 521 minus 380, I get 141. 141 into 10 divided by 389 gives me 3.6247. So when I add 50 to that, I get median as 53.6247. And since it's a distribution of marks, I could say m is equal to 53.6 marks. Now coming to the computation of mode, mode is given by the formula L plus F1 minus F0 divided by 2 F1 minus F0 minus F2, where we define modal class as class interval with highest frequency. And here I am using the notation F1 to indicate the highest frequencies. For the sake of Z, you have to just look into the column of F to identify the highest frequency. So we have values 150, 330, 389. So highest value is 389. Now that is indicated by F1. F0 indicates the previous frequency. F2 indicates the successor frequency of the modal class. And you have class interval 50 to 60 as the modal class. And most of the distribution, your median class and modal class may be same. In some cases, it could be completely different. So always pick that respective class interval, look into the value of L, look into the values of F, the requirement, and then do the substitution. So this will be 50 plus F1. F1 is 389, F0 is 230 divided by 2F1. 2F1 will be 2 into 389, which comes to 778 minus 230 minus successive frequency 142 into class width 10. So first do all the subtractions, then the multiplication with 10, then the quotient, then the addition. So if I look into 389 minus 230, I get 159. So I'll just continue that here. 150 plus 159 into 10 divided by 778 minus 230 minus 142, which is 406. So when I do 159 into 10 divided by 406, I get 3.91. So when I add it to 50, I get 53.9163. So if you look into the actual values now and the actual data, you will see that the values need not be in the data. So now when ಹೇಳ್ತಾ ಇದೀವಿ Z ಅಂದ್ರೆ most repeated. So ನನ್ನ marks data ಏನಿದೆ ಅದರಲ್ಲಿ 53.9 ಅನ್ನೋದು most repeated value, 53.6 ಅನ್ನೋದು middle number. But when you look back into the original data from where the distribution is created, there will be no 53.91, there will be no 53.6. So that's why we said these are all the methods, especially the median and mode. In case of continuous data, it just gives us a real value, gives us an answer or an estimate closer to the actual value, but only at certain times they produce the value same as the original value. So that's why they are not commonly used, especially these formulas in the calculation of median and mode. But you have this in your syllabus, you have to learn the technique, and you could have a problem on finding mean as well as median mode for a continuous case also. Fine. So I'll wind up the class for the day here. So today we have talked about measures of central tendency. We discussed 5 measures: arithmetic mean, geometric mean, harmonic mean, median, and mode. We looked into their definitions, the formulas, and we also looked into the calculation procedures of the three cases of data, which are raw data, discrete frequency data, and continuous frequency data. Okay, so I'll end the session here. Please be with me. Let me capture the list, student list. ಎಲ್ಲಿ ಬೇರೆಯವರೆಲ್ಲ ಎಲ್ಲಿ ಹೊಟ್ಟೋದ್ರು ಬರೀ 15 ಆಗಿದ್ರಲ್ಲ ಹೇಳಿದ್ದೀನಿ ಅಟೆಂಡೆನ್ಸ್ ಆಗಿಲ್ಲ ಜಾಯಿನ್ ಆಗಿ ಅಂತ ಬೇಡ ಅಂದರೆ ನನಗೂ ಬೇಡ. ಓಕೆ ಸೊ